I welcome you all for the next tutorial. This is about Radix Sort technique, Radix sorting technique. So this is one of the different sorting algorithm. It is a non-comparative algorithm. Usually when we say sorting algorithm, we'll compare elements, okay? We'll compare elements, then we'll sort, okay? But here this Radix sort algorithm is a non-comparative algorithm. It avoids comparison. It won't do any comparison. It won't compare a number with another number in the list, okay? So that's why this Radix sort is called as non-comparative algorithm. Okay, it will use different method to sort. Okay, it creates and distributes elements into buckets. If you are having a list of elements, it creates buckets. Sometimes we can say queue buckets. The buckets are in the form of queue. Okay, it's similar to queue data structure. So it creates buckets and distributes the element in the list into buckets. Okay, it places the elements into the relevant buckets. So that's why this Radix sort algorithm is otherwise called as bucket sorting algorithm. The another name for Radix sort algorithm is bucket sorting algorithm. So here the sorting is performed from the least significant digit to most significant digit. Okay, when you are taking numbers, okay, so it starts sorting from the least significant digit. For example, a number is 12, so it checks all the least significant digit. So 2 in the first number. For example, second number is 15. It takes 5 from the second number. Likewise, the sorting is done. So sorting is performed from the least significant digit to most significant digit. The digit in units position, and likewise it goes on tens, hundreds and thousands depending upon the number of digits in your list. Okay, it requires number of passes like all other algorithms. Here the number of passes are equal to the number of digits. Okay, number of passes are equal to number of digits present in the largest number of the list. For example, if you are having 10 numbers in the list, so you have to find out the largest number and you have to find out the number of digits in the largest number. So that much number of passes we have to do to sort the list of elements. It is not, the passes are not related to the number of elements here. In all other algorithms, number of passes, it depends upon the number of elements. Okay, so sometimes n-1, and we'll find out the time complexity based upon the comparisons. Here in this algorithm, so no comparison is here. Non-comparative algorithm will calculate time complexity in a different way. Okay, we'll see the algorithm, then we'll move on to the time complexity. So here these are the steps, algorithmic steps involved in Radix sorting technique. So you have to take the input array, list of numbers, or you can take list of strings or list of characters. So you can take anything, okay, and it is not applicable for the floating point numbers. We cannot sort floating point numbers using Radix sort. Okay, and after taking the input array, you have to find the maximum number in the list. Okay, and after picking the maximum number, you have to count the number of digits in the maximum number. So these are the inputs for your Radix sort algorithm. First is your input array. So from the input array, you have to find the maximum number, and in that number, so you have to count the number of digits in that number. Okay, so because we need to iterate this algorithmic steps for the number of digits in the maximum number. That's why we are finding out this number of digits. Okay, next step, after input receiving all the inputs needed for this algorithm, so you have to create the bucket. The second step is creating bucket, or we can say creating number of queues. Okay, or we can say define number of queues. Okay, so here you have to define number of queues based on the elements range in the list. For example, you are considering only the decimal numbers. So the decimal number ranges from 0 to 9. Okay, so range is 10. Okay, so 0 over a digit to either it is 0 or it will be in the range 0 to 9. Okay, if you are taking words the characters A to Z 26. 26 is the range. Depending upon the range, you have to define number of queues, number of buckets. If you are taking if you are dealing with decimal number you have to create 10 queues. Okay, so 10 indicates the base value of the decimal number, or we can say radix of a decimal number. That's why this type of sorting is called as radix sort. Radix value the base value we are taking. That's why it is called radix sort. Okay, and the next step is, after creating the queues based on the range, okay, you have to consider, first you have to consider the least significant digit, okay, of each number in the list. Okay, you have to consider the least significant digit, and based on the least significant digit, you have to insert the number into the respective queue or respective bucket. Okay, so either we are going to insert it into the queue, or we can call that queue as bucket. Okay, so bucket kulla ulla podrom சரியா, ஒவ்வொன்னாத்துக்கு உள்ள போடுறோம். queue அப்படினா என்ன operation? Insertion operation. Insertion NQ. Okay, NQ DQ operation இங்க நடக்கும். background coding எழுதும்போது you have to use all those operations. We are looking onto the algorithmic structure மட்டும்தான், detail of programmatical code நம்ம பார்க்கல. Okay, so insert each number into the respective queue. So if the least significant digit is 0 அப்படினா place it, insert it into Q0. If the least significant digit is 9 அப்படினா insert it into queue number 9. Okay, likewise you have to insert. Then after inserting all the numbers into its respective queues, you have to collect all the numbers in order. Okay, from Q0 to Q9 you have to collect all the numbers in the order. Okay, in the insertion order. Okay, you have to collect all the numbers. After collecting all the numbers, you have to consider these lists. Okay, so this updated list, and you have to repeat the steps. Repeat the steps 3 to 5 based on the next significant digit. So we have taken the least significant digit in the first step. Then in the next step, you have to consider the next significant digit. Likewise, it goes on up to the most significant digit. So these are the steps involved in radix sort technique, and we'll see the example. So we here I have taken an example list. It contains 3, 6 and 8 numbers. Okay, so 2-digit number as well as 3-digit number. So maximum we are having 3 digit. So the maximum, first you have to find out the maximum element. So here the maximum element in the list is 901. So in the largest number, so only 3 digits are present. So make all your numbers as 3 digit. If your list contains 2 digit, make it as 3 digit number, so that you may not get confused. Okay, while placing the number into the queue. Okay, so number of digits here is 3. So how many passes required? 3 passes required. So first pass. So in the first pass, so you have to insert element based on the least significant digit. So the digit in the unit position. So you are going to consider the digit in the unit position. So here I have marked the digit in the unit position in my elements list. Okay, so see, I have 10 queues. I have numbered each and every queue. So this is queue number 0, 1, 2, likewise it goes on up to 9. You have to take each and every element, consider each and every elements which digit, least significant digit. Okay, so all numbers least significant digit you have to consider. If it is 2, place it in queue number 2. See here, 82 is placed in queue number 2, and 901 is placed in queue number 1, and 100 is placed in queue number 0. 366 it is placed in queue number 6, and 423 it is placed in queue number 3, and 143 is placed in queue number 3 again, above the last inserted element like q எப்படி work ஆகுமோ அதே மாதிரி தான் work ஆகும். Okay, right. So after inserting all the elements in the list into their respective buckets or respective queues, you have to collect all the elements in order from q0 to q9. In q0 we are having 100. Okay, and in q1 you are having 2 elements. You have to collect in the order you have inserted. In which order we have inserted? First we have inserted 901, then we have inserted 321. Q la eppadi dhan delete agum? Deletion operation happens with the help of front pointer. Appadana front element tha first delete agum. So in that order you have to remove. So 901, then 321, then 82, then 423, then 143 will be removed. Then 366 and 538. So that's all about pass 1. Okay, then pass 2. For pass 2 you have to consider this list, updated list. Okay, so in pass 2, so list after pass 1 is here. So here you have to consider which significant digit, tens position. So in the last pass we have considered the unit position digit, and here in this pass we are going to consider the digit at tens position. Okay, so insert based on the next significant digit, tens digit. Okay, tens unit base pani we are going to insert. Okay, so here 100, the tens position is 0, so you have to insert it to the bucket 100. Likewise you insert all the elements. Okay, after inserting all the elements into their respective queues, you have to collect the elements in order. After collecting it in order, so you have to take those list for the next pass. Okay, so list after pass 2. So here in this pass you have to consider the most significant digit, only one more digit, so you have to consider the hundreds position. Okay, so according to that significant digit you have to insert all the items into the respective queues. So here 82, for 82, no, 82 is a 2-digit number. So already I told you, in order to make it 3-digit you have to place 0. So no meaning in adding zeros before a number. Okay, so you have to place 82 in which bucket? 0th bucket. Okay, then likewise you insert all the elements in the relevant queues and you have to collect. So after 3 passes you have the sorted list. So this is about the Radix sort technique. Okay, so no comparison is done here. So without comparison, so here the elements are ordered. Okay, and here Radix sort algorithm, it takes much space. Okay, so for each and every queue we need space in a computer memory. Okay, so it takes much space. So here the order of the time complexity is given in this way. So d into n plus k. D means is the number of digits in your list. Okay, so here in our example it is 3. Okay, or we can say number of passes required to sort the list, both are same. So 3 into, and inside each and every Radix sort you have done 2 things. Total number of list. Okay, we are having n elements in the list, and according to the range, if it is a decimal number na, we are having 10 queues. Appa n plus k times we have to do the operation. N elements irukku appadina k ranges la nama podanum. Different ranges we are having 0 to 9. Appa n and the element in the range on the range la we are going to place, we are going to insert. Okay, it takes some time. So n plus k, so d into n plus k. Okay, in each and every pass n plus k time is needed, and totally we need d into n plus k. It requires more space in computer memory. So this is about the Radix sort algorithm, Radix sort technique. So exercise problem is given, sort the list of numbers given here with the help of Radix sort. You, after watching this tutorial, you try to sort the numbers with the help of Radix sort algorithm. Thank you for watching.